So here we can say that the electric field is given by E equals AR. So it is linearly increasing. Okay, now since it is linearly increasing, the setup must have been the inside of a solid non-conducting sphere. Why it's non-conducting? Because the charges, they stay as like wherever they are, they don't come to the surface, and it's a solid. So like we have the entire derivation. We will, okay, we can do also the derivation. So this is the Gaussian surface which is considered. So we have integration of E dot dA is equal to Q enclosed divided by epsilon naught. So this is E into 4 pi r square, and keep it in mind that r is less than the radius of the sphere. This is equal to the Q enclosed. Now the total charge is Q, so Q divided by 4 by 3 pi r cube into 4 by 3 pi small r cube. That much charge is enclosed. Gone. Okay, and this is divided by epsilon naught. So if you see here r square, so this becomes, so therefore the electric field is going to be Q r upon r cube into 4 pi epsilon naught. So you see here it's linear. Okay, now the charge contained in a sphere of radius a centered at the origin of the field will be, okay, so now what is the charge which is contained in this radius a? Okay, so at least we know this now, that a is equal to Q over 4 pi epsilon naught r cube. Now for this radius, let us say now this is radius a, how much charge is there? So the charge will be 4 by 3 pi into a cube into, now whatever was the entire charge we had considered was q by 4 by 3 pi r cube. Why we have done this? We have considered the charge to be uniformly distributed. When we have the charge uniformly distributed throughout the volume, then only the electric field will be coming out linearly. Okay, so therefore we have so this is the charge which is contained, Q enclosed within a radius of a. Gone. Okay, so now Q is 4 by, so we just substitute, so this is a cube into 4 pi epsilon naught r cube into a. Okay, so this is Q and divided by r cube, so gone, so this becomes 4 pi epsilon naught into a cube into a. So therefore the answer is C. And we can see here also like we derived it, but generally we can remember this, that the electric field inside, if you see, it is linearly dependent upon r, and we can see this in the graph also.